All right, welcome back everybody. This video deals with material from Unit 1, Section 9 of AP Calculus, connecting multiple representations of limits. So up to this point in time, we've talked about, how we describe limits verbally. We've talked about how we can represent limits graphically, how we can represent them numerically using a table of data, and how we can represent them algebraically by using functions or equations. In this lesson, we're going to look at a bunch of different contexts where we look at those particular limits from all the different types of representations that we can, or at least multiple representations. Before we get too far into this, I'd like to give appropriate credit to the AP Classroom website and the daily videos that they have there, because I have lifted a couple of these examples as is from there and made some modifications to some examples that they use in their video on connecting multiple representations of limits. So shout out to them, thank you very much, and let's get down to business. So let's look at example 1. It says the graph of g of x is shown. Which of the following could be a table of values for g? Okay, so looking at this graph of g of x, I'm looking for characteristics that will help me understand which of these tables connects to this particular graph. And I have one very important characteristic that jumps off the page to me right away in helping me identify which of these tables represents g, and that is this point right here, because that point, falls out of line with everything else on the graph. And it looks like that is the point that when x is 4, g of x is equal to 1. And so no matter what, my table that has my answer is going to have 1 as the value of the function g at 4, which enables me to eliminate this first choice and this second choice, because the values at 4 are something other than 1. And that enables me to narrow it down to these two answers. Now, the one other thing that I can see from this graph very easily is that as I'm approaching 4 from the left, and as I'm approaching 4 from the right, those values are approaching, 2 and change, which both of the tables appear to be approaching 2 and change. But what I see is that the function is increasing as we move from left to right through the point where x is equal to 4. And so the values in our table need to increase as we move from left to right, and that tells us that our answer choice here is going to be C. Okay, there's example 1. Whoop. Example 2. If f is a function such that the limit as x approaches 1 of f of x does not exist, which of the following could be a representation of f of x? So really what we're saying is, in which of these three scenarios is it possible that the limit as x approaches 1 does not exist? So let's start with choice 1, our table here. It looks like we've got a value at 1, but we also notice that the values appear to be approaching the same value from left to right. But I will call you back to our lesson all the way back when we talked about estimating limits from tables of data. The thing is we don't know what happens between 0.999 and 1, or between 1 and 1.001. We don't know for certain what happens. For instance, these numbers could dramatically shoot down as, I could have at x equals 1.0001, the function value could be -5. We just simply don't know for sure. And so it is possible, based off of this table of data, even if it may be unlikely, it is possible that this limit does not exist as x approaches 1. Okay, so then I'm going to look at choice II. F of x is this piecewise function. So what I need to do is I need to check and see, does the limit as x approaches 1 exist on this particular function? And so I'm going to take the limit as x approaches 1 from the left, which means I'm going to use the branch that is to the left, which is this branch right here, 2x plus 7. So that's the limit as x approaches 1 from the left of the quantity 2x plus 7. I can just go ahead and substitute 1 in there, and I get 9. And then I'm going to look at the limit as x approaches 1 from the right. And for that one, we need to use the bottom branch of the piecewise function. And we'll substitute 1 in there for x. 1 plus 8 minus 3 gives us 6. Those two values aren't equal, the limit from the left and the limit from the right. So indeed, the limit as x approaches 1 of this function does not exist. So this one also does not exist. So that narrows us down to 2 answer choices. We're either going to have C or D as our final answer, depending on what happens here in choice I. And we're looking at this and the limit as x approaches 1 and seeing if it's possible that the limit as x approaches 1 does not exist. If you look at this graph, you see that the limit as x approaches 2 does not exist, but right here at 1, the function is approaching the same value from both the left and right, and therefore this limit does exist. And so the only two that could be representations of f of x, if the limit as x approaches 1 of f of x doesn't exist, are these two. And so our answer choice is C. All right, let's go on to example 3. I think I changed this one up a little bit. Example 3, select all the answers that apply. As x becomes arbitrarily closer to negative 4, h of x becomes arbitrarily closer to 10 square root of 2. Which of the following could possibly not represent h of x? Okay, so the question is, which of these could we come up with some way that they're not functions that as x becomes arbitrarily closer to negative 4, h of x becomes arbitrarily closer to 10 root 2. Now, here in part A, we see that the limit as x approaches negative 4 from the right is indeed 10 root 2. But what if, say, the limit as x approaches negative 4 from the left approaches some other value, like 8. Okay, then we would not really be correct in saying that as x becomes arbitrarily closer to negative 4, h of x becomes arbitrarily closer to 10 root 2. It does from one side, but not from the other, and so really it's not appropriate to say that h of x becomes arbitrarily closer to any value if I have those two situations. If instead the original statement said as x becomes arbitrarily closer to negative 4 from the right, h of x becomes arbitrarily closer to 10 root 2, then this could represent h of x, but I'm going to say that I can come up with a way that this might not. And that's all I'm looking for. It could possibly not represent h of x. In part B, h of negative 4 equals 20. It's entirely possible that I can come up with some function where h of negative 4 equals 20, but that h of x does not become arbitrarily closer to negative 4. So this one also could possibly not represent the function h of x that we're talking about here. All right, let's see. H of x, the piecewise function here. H of x equals 10 root x plus 6. And square root of 2 times the quantity x plus 16. If I find the limit as x approaches negative 4 from the left, I'm putting negative 4 into the bottom branch here, and that gets closer to 12 root 2. So it's entirely possible that this is not h of x because, in fact, it's certain that this is not h of x because that alone does not approach 10 root 2. The other branch does approach 10 root 2 if I substitute negative 4 in there. But again, could possibly not represent. If we're saying that x becomes arbitrarily closer to negative 4, h of x becomes arbitrarily closer to 10 root 2, we want that to happen from both sides. So this one works as well. And then part D, if we look at what happens as x approaches -4, it appears the function value is approaching 0. So again, that one's not going to represent. So it is entirely possible that none of these are actually the function h of x that we're talking about in this example. All right, last one. Example 4. Let f be a piecewise linear function increasing for x greater than 0. If the limit as x approaches 5 of f of x equals 2, which of the following could represent f? Okay, so let's take a look at these and see. Let's start with this part. If the limit as x approaches 5 of f of x equals 2, which of these have a limit as x approaches 5 being 2? And I'm going to work from the bottom here. We see here on the graph, as x approaches 5, this graph does approach 2 from both the left and the right. If I do some quick substitution and find the left-hand and right-hand limits here in choice II, substitute 5 into the bottom branch, it becomes 2. Substitute 5 into the top branch, it also becomes 2. So the limit of this also approaches 2. And in part I, it's possible that the limit as x approaches 5 of f of x could be 2 here as well, if we look at these values. So all of them pass this test. The question is, which of them pass this test? Is it a piecewise linear function increasing for x greater than 0? So looking at choice I, the values are increasing up to 5, but then as we go above 5, the values are decreasing. So this one does not work. The slopes of both branches of the piecewise function in choice II are both positive, and therefore that function is increasing, so that one does work. And you can see from the graph in choice III that though that function is increasing as x is greater than 0, and so choice II and III both work, and so choice C is going to be our answer. All right, that wraps it up for this video. For those of you who are in my class, make sure you complete the My AP assignment listed at the bottom of the page. We'll see you next time for section 110, exploring types of discontinuities. Have a great rest of your day, and I'll see you next time. Bye-bye.